So how we can analyze the complexity means, say for example, the same bubble sort based on the number of steps, the logical instructions what we are using. The bubble sort time complexity based on the time complexity analysis in best case. Best case means, say if the numbers are in ordered form and partially ordered form, and within a less number of iterations we are getting the result means that is best case. Say for example, you are preparing yourself for the exam. So whatever questions you studied, you practiced, you know very well, that question comes in the exam, then that is the best case. Average case, you studied the entire syllabus and you remember almost all the topics, but one or few topics you skip. And if you are getting 80% of the questions from what you studied and 1 or 20% from unknown topics, then it is called average case. It means the numbers are not completely ordered, but little bit ordered out of 1,000 numbers or 10,000 numbers. And in case of worst case, almost to the end, all the numbers are in unsorted form. And so it is, it means if you go through the entire topics, if you are well versed in all the concepts, then only you can able to attend the exam means, so it is worst case. Okay. The same way, as we discussed in the previous topic, depending upon the number of inputs, depending upon the complexity of the particular algorithm, and based on the in case of sorting and searching, if the searching element is in the first position itself, even though if there are 10,000 numbers, the searching element is found in the first location itself, then automatically the process will stop. But there are only 100 numbers, but the searching element is in the last position. Anyhow, you need to undergo 100 iterations. So like that. So this best case occurs when the array is already sorted. The algorithm makes some one pass through the array with no swaps. So if the array is already in sorted form, so it means no need to perform the swapping also. So if you perform 1 or 2 swapping, then that also occupies your CPU time, and it needs some time as well as memory space, and some swapping should be done. So, so if the list is already in ordered form, then that is the best case. The average case, so here for n numbers, only one pass is enough. For given n numbers, the time complexity of bubble sort, in best case, it is order of n. In average case, for n numbers, at least you need to go through n square passes. Occurs when the array elements are in random order, and average each element is compared to half of the other elements. So each and every number is compared with the remaining elements, and swapping also happens. Then it is called average case. And in case of worst case, so the worst case algorithm is order of n square into order of n to the power of n factorial n caps n caps 2, and order of n square. So occurs when the array is sorted in reverse order. So we are looking for a ascending order, but the number is in the descending order. Then that is the worst case. Each element must be compared to every other element, resulting in the maximum number of comparisons and maximum number of swaps. So you got the idea? So complexity of any algorithm is in terms of time complexity and space complexity. Time complexity means how much time we need to run the project or program if you are using the particular algorithm, say bubble sort algorithm or selection sort algorithm or linear searching algorithm. And space complexity means how much memory space you require to load the program and to execute the program. So if the program is having only 15 lines of 15 executable lines, then the memory space will be very less. But the same logic program, some people will add more than 150 lines of code, 200 lines of code. It depends on the programmer. They will put a lot of escape sequence, a lot of formatting, lot of linear statements. So then the number of code can be extended. And for to store each and every content, each and every character alphabet, we need memory space. Say for example, to analyze the complexity, so if you take the binary search, So in the previous example, we discussed a linear search. Now we are talking about binary search. What do you mean by binary? Search means we know very well, searching for an element. Say in the class of 70, your in the class 10th is 72. So if I like to know who is the 55th, 55th student in the serial number, then it is searching for a particular student in the list. The searching may be linear search from 1 to, we will come across all 50 students, then we will reach the 55th student. We like to see whether the 55th student in the attendance is present all the classes or not. What is his attendance percentage? That is sequentially we will search, or we may search binary. Binary means already the attendance downloaded from the VTOP is in ordered form from serial number 1 to 72. So if it is binary, find out the middle element or pivot element, find out the length of the array. Length of the array is 72. 72 divided by 2. What is the value of 72 divided by 2?
36.
What is the answer of 72 divided by 2?
36.
What is the middle number? What is the middle number? 36. So the searching student is 55. The 55 will be in the 1 to 36 or 37 to 72, because the name list is already in
37
the
to
ordered.
72.
The name list is in already ordered form. So it will be in the second half from 37 to 72. So we will discard, we won't search the searching element in the first half. We'll take only the second half. So we'll go for the recursive binary search. So once again, you call the function from 37 to, so we will change the index. The first index will be 37 now, and the first of the array will be discarded. We will take only the second of. 37 is your first array element, and 72 is your second array element. From 36 to 72, we have 36 students. So we will find out the middle element. 36 divided by 2. What is the mid value?
18.
18. So we'll figure from 36 to 18. What will be the
54.
position?
54th position.
What is the position from 37 to 15? 37 plus 15, so 16.
18, no ma'am.
18.
37, 54.
Yeah. So, but our searching element is 54. 50. We are searching for 55. Now, the mid element is 54. Searching element is 55. Then the student will be available in the second half, 54 to 72, not from 37 to 54. So again, we will discard 37 to 54. We will take only the divide and conquer technique. We will take only the first element will be now 54. Last element will be 72. Again, we will find out the mid value. For the 16 students, mid element is 18. Na? So out of 18 students, the midpoint is again 9. So
None.
that we will proceed. So that is binary.
55 to
Yeah, divide and
60, 63.
yes. So say for example, merge sort. So this is the logic. So especially in the merge sort, we are using designing the algorithm. Several techniques, patterns for designing algorithms exist. Incremental approach, build the solution one component at a time. And the divide and conquer approach means breaks the original problem into several smaller instructions of the same problem. Results in recursive algorithms, easy to analyze complexity using proven techniques. So in divide and conquer, what we will do? It is a methodology. It involves divide stage, then conquer stage, then combine stage. Three stages are there. In divide stage, what we will do? Express problem in terms of several several subproblems. Say for example, you're supposed to get 61 credits to get the degree, but all the 61 subjects you are not registering the first semester. What you are doing? The same 61 credits is offered to you in 8 semesters. In first semester, you are taking around 3 into 5 or 6, 18 credits or 20 credits. So every semester you are taking 20 credits or 21 credits, maximum 18 credits. So first semester 18 credits, next semester 18 credits, next semester 18 credits, like that. 8 into 20. So like that you are completing. So if you see all to 61 credit subjects or almost 54 subjects at a time, if you register and if you study all, it is not possible to complete. So we are offering only 5 subjects per semester or 6 subjects per semester. And for so in that way you are dividing and dividing and you are studying all the subjects. But if you divide, so all the topics, all the concepts are not studied in the same subject. Again, the concepts are divided and put into different subjects. Puts using C++, data structures, Python programming, computer networks, AI, ML, like that. The same concepts interrelated to each other with the same domain, computer science and engineering, but they are put into different subjects. But you need to study all the subjects and you have to gain all the knowledge to get the degree. And overall, you have to get all the 62 credits or 65. How many credits you are getting? 61 or 121? How many credits? So in the divide stage, express problem in terms of several smaller subproblems. Whatever may be the problem given to you, don't see the problem in front of your eye or very close to your eye. Put the problem in a different place and see it from the long distance. So if you keep the problem just near the nose or near the eye, it will look very big. But if you keep the problem somewhere and if you see as an external person, you will get lot of logics or you will get this way to get the solution for the or to solve the problem. In the same way, divide the big problem into small problems. Solve each problem at a time so that you will get the solution. Say if the problem is very big, you are dividing the problem into 10 small problems. You are solving each problem one day. And within 10 days, you can solve all the problems and you will get the solution for all the 10 problems. Combine together to get the overall solution. Concur stage, solve the smaller subproblems by applying solution recursively. Smallest subproblems may be solved directly. Then combine stage, construct the solution to original problem from subproblems and combine all the subsolutions of smaller subproblems to get the complete solution. So divide the problem into subproblems, solve the problems in the unit level, get the solution for all the subproblems, and combine all the subproblem solutions, and you will get the solution for the overall problem. The same logic we are applying in merge sort also. Say here what we are doing. You are given some list of n numbers, maybe 10 numbers or 50 numbers. It is in the unsorted form. What you will do, you will find out the mid element n by 2. You will get the mid element. So we will take n by 2, n by 2. So if there are 100 elements, 50, so 50, one list, another 50, another list. Again, divide the 50 elements into 25, 25. Like that, you go to the unit level and solve mid sort the elements in the unit level. Once we get the solution for the sorted elements, two sorted list we will get. It is in the unsorted form. Divide the unsorted form into two of. Find out the sorted list. But now we will be having the sorted list of n by 2, sorted list of n by 2. Merge both the sorted list. We will get the answer for the sorted list of n numbers. All the numbers are sorted. Divide the split the n elements sequence into two subsequences of n by 2 each. Concur recursively, sort the two subsequences, combine, merge the two sorted subsequences to get the final solution. So in binary search also, we'll take the first half and second half, the same logic, then we'll proceed. So in the best case occurs when the target element is found in the middle of the array on the first comparison itself. So in the binary search, we'll divide the list into two half, first half and second half. When you find the middle element is matching with the searching element, then the answer will be found in the first iteration itself. So that is the best case. In average case occurs as an algorithm repeatedly divides the search intervals in half, requiring log n n log n comparisons in the worst case. And in big O notation, we will it describes the upper bound of the algorithm's running time. So for each and every statement in the algorithm, we will find out the computation time. Then we will combine together to find out the overall computation time. So how we can make use the algorithms as a technology to find out the solution means, even if computers were infinitely fast and memory was plentiful and free, but creating programs which occupies very less memory space is an efficient programming technique. So study of algorithms still important, still need to establish algorithm and correctness. Since time and space resources are infinite, any correct algorithm would be real world computers are fast but not infinitely. So memory is cheap but not unlimited. So whatever in olden days, even the desktop will come with 250 MB RAM, or not more than the hard disk capacity itself 1 GB hard disk, and RAM will be 512 RAM, 512 KB MB, in that range. But nowadays the memory cost is less only. But anyhow, memory writing programs with less memory space, which occupies less memory space and takes less time, is an important efficiency parameter. So what is efficiency means? The time and space efficiency are the global or the goal for any programmers. Algorithms often differ dramatically in their efficiency. Say, for example, two sorting algorithms. Say, if you take insertion sort as well as merge sort. So the time efficiency is for insertion sort is where C1 is the error factor. Time efficiency is n square. For merge sort, time efficiency is n log n. C1 is the constraint or small error factor. So here insertion sort for n numbers, it takes n square, but merge sort, it takes log n. So which is bigger, which is smaller one, which takes lesser time? N square is a bigger one, or n log n is a bigger one? Here, Dosi, Pranav.
Yes, ma'am.
Yes, which method is the insertion sort is efficient one?
Ma'am, the merge sort would be more efficient.
Okay. So efficiency answer depends on several factors. So they are nowadays everything logic program, everything is available. Nowadays, whatever programs we are creating or whatever projects we are creating, we are not creating from the scratch. The existing code is reused. Maybe the project is written in some other language, maybe written in C++ or some other Fortran or COBOL. So they may be upgrading the language, or they may be upgrading the front end or back end, or they may take the logic from some other project, because the programming so real world projects are almost 100 years old, 150 years old. So almost every logic is available, even if you are going with AIML or IoT or cloud based projects also. So everything is almost available. So the thing is how we are improving the efficiency in terms of time, space, and platform independent, and using open sources and open source resources, and
Ma'am, in terms of spaces, insertion sort is better than one sort.
for n numbers, it takes n square. So say for example, n is 10, 10 square is 100. For 10 numbers, 10 into log n. Log n will be smaller value, no? So 10 into log n,
Yes, ma'am.
then the value will be less than 100. So definitely quick sort, binary sort, merge sort, they are more efficient compared to sequential sort, insertion sort, bubble sort, selection sort. They are basic fundamental algorithms. The binary, merge, quick sort, shell sort, heap sort. They are using dynamic memory allocation as well as they are using advanced technology like divide and conquer. So definitely their efficiency in terms of time and cost will cost and memory is less. So the how we are evaluating the efficiency means in terms of several parameters, speed of the machine performing the computation and internal clock speed. So the clock speed is measured in terms of if you open the laptop or if you see the configuration, you can find gigahertz per second. So the clock speed is that much second. So a pulse will be generated within that speed. So based on that, each pulse is required to perform each and every task. Say if you are performing C equal to A plus B, it is a 2 byte instruction. A plus B addition needs 1 byte, one pulse, and storing the result in B, C equal to A plus B. So it is a 2 byte instruction. So that needs 2 clock pulses. So if the speed of a clock pulses is very high, then the efficiency will be very high. Say if you are riding on a vehicle with high speed, then you can reach 60 kilometers per hour or 100 kilometers per hour or 200 kilometers per hour. Depends within 1 hour how much distance you are covering. The same way based on the clock speed, gigahertz per second, this efficiency will increase. Internal clock speed, shared environment, how many resources, whether it is parallel processing, pipeline processing, the memory, everything shared, virtual memory is available, cloud memory is available, and input output needed by the algorithm, whether it is depending, the algorithm is expecting the output from some other program, main program or from some other program. So if the dependency is there, then the efficiency will reduce. And quality of implementation. So what kind of lines of code you are using, whether you're using pointers or you are using call by value, call by reference, or recursive functions, or normal iterative statements. So the coding, efficient coding also important. If you are using jumping statement, go to statements, then that will reduce the time. And unwanted jumping, unwanted breaks, unwanted continuous statements. They are that's what, if you take C Python or C++ or Java, the go to, continue, break, unnecessary jumping is totally eliminated. No, if you use, you can use, it's available, but if you use, the efficiency will go down. And compiler optimization, what kind of compiler you are using, and implementation details, what kind of data structures you are using in the coding. So these are all the parameters. Size of the problem instance, most stable parameters used as independent variables. So the variable should be global variable or local variable. That variable and the data should be available during the execution for that particular function or main program. If it is waiting for the input from someone or from the end user or from some other function, if dependency is there, coupling and cohesion is there, then that will reduce the efficiency. So these are all the parameters that determine the efficiency of any program, and almost all those parameters are based on the algorithm what we are using. As we already discussed, if you take the efficiency of insertion sort implemented by an ACE programmer and run on a machine A that performs 10 to the power of 9 instructions per second. That particular computer CPU can perform 10 to the power nanoseconds per second, such that time efficiency is given by, for insertion sort for n numbers, 2 into n square instructions per second. So where C1 is 2, it means a small error factor. And in case of merge sort, with the same 10 to the power of 7, this is 9 nanoseconds. Here, less than that. Here, this particular machine is slower one, instructions per second, such that the time efficiency is given by 50 n log n instructions. It is equal to, so it depends not only the, here they are using high speed in the machine, nanoseconds. This particular machine is 10 to the power of 7. So this time, so based on that, even the formula is, the algorithm is good, but the machine is slow machine, so the time will be more. Here the error is less, the error factor C1 is less in this particular machine. Here the error factor, they are using that C, na? C factor, C1 we saw in the previous, they mentioned. The formula they mentioned, C1, where C1 is the minor error factor. Actual, the if algorithm is big O of n log n, big O of n square. But depending upon the machine, the error factor C1. So if you are using a good machine with high speed, this particular sorting algorithm itself, it will give you, it will work in less time. But your machine is a slower machine, for say the Pentium machine or something, say 10 to the power of 7, then it will take long time. Even the algorithm is good, but that machine is not good. So there are so many parameters which determine the efficiency of any particular algorithm. Say for example, this particular graph gives you a comparison. See, all those things for your understanding purpose only I added to understand what is what. But you can understand, but you need not remember. It may be somewhat advanced features. So you can follow the textbook also, but if by seeing all those things, you can easily understand. So the size of the problem in 10 seconds and seconds. So insertion sort takes, so when the number of size of the problem is 65, it takes 10 seconds. And the size of the problem is only 25 or 33. If you are giving only 33 inputs, it completes within 2 seconds. If you give the input up to 65, then it takes 10 seconds. It's an exponential growth. But if you take this particular merge sort, if you give 33, it takes 2.5 seconds or 3 seconds. Even if you give 65, it completes within 5 seconds. So even when the input increases also, the merge sort gives you, works in less time. When the input increases, the insertion sort takes more time to execute. So the ideal time, ideal input for this particular insertion sort is, if you give up within less than 35, it may give you more efficient. So there is a cutting point. So like that, we can understand the logic. So any doubt today's complexity, today's topics, algorithm design and complexity. So today we,
No, ma'am.
what
Ma'am, will you upload this PPT?
yes, I will upload. So if you take the algorithm design, how to design the algorithm and how to understand the complexity of the algorithm. And parallelly, you open the textbook and go through the textbook also. For your understanding purpose, I included all those things, some interrelated concepts. Have you gone through the textbook? So you should create the habit of reading the textbook. How many of you gone through the textbook? So the window will close in another 10 minutes. How many of you gone through the textbook? I am asking now. So go through the topics. If you have any doubt, ask me in the next class. Now you should be familiar with what is bubble sort, what is linear search. Those topics are mentioned in the second unit. Anyhow, you are having the programs with respect to those things. Okay, as we were discussing about what is merge sort, and it is using divide and conquer technology. So if you take the merge sort, only 51 students are. So if you take the merge sort, so you are given a list of n numbers. So what we will do, so these are the input values. It is in the unsorted form, initial sequence. Then what we will do, we will merge first two numbers. We are getting an, we will compare these first two numbers, and these two, by after comparison, the second one is smallest, first one is biggest. So we are swapping. Now this particular list, small list, 2 comma 5 is in sorted form. Then we are comparing the next two numbers. Among these two numbers, 4 is small and 7 is greater. So it's already in sorted form. No need to swap. Now it is in sorted form. Again, if you take the next two numbers, 1 and 3, 1 is small and 3 is greater. No need to swap. Now this particular small list is in sorted form. Again, here also it is in sorted form. Now what we will do? We will take the sorted two list, the second iteration. So now we'll compare these elements. This element is compared with this element. 2 is smallest, so it is mentioned, and 4 is greater, so it is mentioned. Again, 5 is taken, 5 is compared with the 4. It is 4 is small, so we'll leave it. Again, 5 is compared with the 7. So 5 is mentioned, then 7. So by we are sorting these two, we are merging and sorting these two lists. The same way, these two list is compared and sorted. Now here also this is sorted in, this is also in sorted form. Now we'll take this number. This is compared with all other numbers. So now when compare, 2 is compared with 1, 1 is small, that is mentioned. 2 is mentioned in the second position. Again 2 is compared with the 2. So again both are same numbers. We'll mention 2. Again 2 is compared with 3. 2 is small. Again 2 is compared with 6. So 6 is bigger number, that is mentioned next position. So then 4 is compared with this, and 5 is compared with all numbers. 6 is compared with all numbers. So at the end we are getting the sorted list. So initially all the numbers are in unsorted form. These two numbers are sorted. Then these two sorted list are sorted. Again, these two sorted list are sorted. Here also we are using the divide and conquer technique. So sorting and merging, sorting and merging, sorting and merging. So the logic is given. I will try to upload this PPT in Google Classroom. You can go through the content. And here, if you analyze the that runtime complexity, So so here we go of one, order of one. For loops, it is repeated for n times, order of n. Again, the assignment statements takes order of one, and every for loop, depending upon the number of elements in the for loop comparisons, it takes order of n. So two order of one statements, two order of n statements. So combines the sorted subarrays A of p to q and A of q plus 1 to r into one sorted array, and make use of two working arrays L and R, which initially hold copies of the two subarrays. Make use of the sentinel value infinity as last element to simplify the logic. So while computing the computational time order of O, big O notation. So the assignment statements will take order of one. So this is an assignment order of O. One instruction per second. It is a 1 byte instructions. But these instructions also 1 byte, but that will be repeated for loop for n times. So for every iteration, order of one, order of one, order of one. So for n iterations, order of n. So here it is an assignment process. It takes only order of one. So these instructions need order of one, order of one, and this is also need order of one. For loop takes order of n. This for loop takes order of n. This assignment process takes order of one. For loop with n values, n iterations takes order of n. So like that, each and every instruction will be given how many iterations we are performing, how much time we will calculate. Then we are calculating how we are getting this value. So for merge sort, time complexity T of n for n numbers, time complexity T of n is 2 is the error factor, T time factor of n by 2 plus order of n. For n numbers, big O of n by 2. So the merging process needs order of n. Merge sort needs order of t by n by 2, and merge sort takes, so they given some split up. But you need to understand, but only these topics, calculations and all, they will study in the design and analysis of algorithms. But you should know what is what. Okay, we'll end the today's class. So you go through the, I will upload the PPT, go through the topics, go through the textbook also. If you have any doubt, ask me in the next class. Any other doubt? Shall we end the class? Okay, thank you all.